24 days from now, we will know the truth. On March 16, 2026, the interstellar object designated 3I, Atlas, will pass within 53.4 million kilometers of Jupiter, the largest planet in our solar system. That passage will either confirm it is a natural comet following predictable gravitational physics, or it will prove something else entirely. But we do not need to wait until March to understand that 3IATLAS is unlike anything we have encountered before. Since its discovery on July 1, 2025, this object has accumulated a list of anomalies so extensive, so improbable, and so mathematically impossible that the question is no longer whether it is strange. The question is whether the strangeness is coincidence or intention. Let me take you through every documented anomaly chronologically, using only verified observations from peer-reviewed sources, space agency data, and Hubble Space Telescope imaging. No speculation, no conspiracy theories, just the facts as they have been recorded by the world's most sophisticated astronomical instruments over the past 8 months. By the end, you will understand why an increasing number of scientists are privately questioning whether we are observing a natural object at all. Anomaly 1. Discovery location, the 1st of July 2025. 3I. Atlas was discovered by the Asteroid Terrestrial Impact Last Alert System in Hawaii on July 1, 2025. The discovery itself was unremarkable. Atlas routinely detects new objects, most of which turn out to be asteroids or comets from our own solar system. But the location of discovery was extraordinary. When astronomers calculated the orbit backward from the discovery position, they realized that 3IATLAS had already crossed the orbit of Jupiter. It was discovered inside the orbit of the largest planet in our solar system, already deep within the inner solar system. Both previous interstellar objects, Oumuamua and 2I, Borisov, were detected much farther out, beyond Jupiter's orbit, giving astronomers months of advance notice to prepare observation campaigns. 3IATLAS appeared suddenly, already well inside our defensive perimeter, so to speak. The probability of discovering an interstellar object only after it has penetrated this deep into the solar system is low. We have better detection capabilities in the outer system, where objects move more slowly and spend more time. Finding it only after Jupiter suggests either it was extremely faint and difficult to detect, or it appeared suddenly through some mechanism we do not understand. Anomaly 2, Mass and Size, July 2025. Within days of discovery, astronomers calculated that 3IATLAS is massive, approximately 1 million times more massive than Oumuamua, approximately 1,000 times more massive than 2I Borisov, and it is moving faster than both previous interstellar visitors, with an inbound velocity of approximately 69 kilometers per second. Here is why that combination is profoundly improbable. Interstellar space is not densely populated with large rocky objects. The rate at which interstellar objects pass through any given stellar system depends on the density of such objects in the galaxy and their typical velocities. Based on the detection rate of Oumuamua and Borisov, astronomers calculated the expected frequency of interstellar visitors of different sizes. Objects the size of 3IATLAS should arrive perhaps once every 1,000 years, not once per decade. Professor Avi Loeb from Harvard calculated that there is not enough rocky material ejected from other stellar systems to naturally deliver an object this massive to the inner solar system at the observed rate. The probability is less than 0.1%. This suggests that 3I/ATLAS may have targeted our solar system rather than arriving by random chance from the reservoir of interstellar material drifting through the galaxy. Anomaly 3. Non-gravitational acceleration, July-August 2025. By late July, astronomers tracking 3I/ATLAS noticed something unusual in its trajectory. The object was not following a purely gravitational path. It was exhibiting non-gravitational acceleration, meaning forces other than the sun's gravity were affecting its motion. This is common for comets. Outgassing from solar heating creates jets that act like tiny rocket engines, slightly altering the trajectory. But 3I/ATLAS was not showing typical cometary activity. No visible tail, no obvious coma of gas and dust. Spectroscopic observations showed a surface composition that did not match typical comets, with too much metal and not enough volatile ices. Yet the trajectory clearly indicated something was pushing it off a purely ballistic path. Small course corrections, subtle adjustments that required some kind of force. The magnitude of the non-gravitational acceleration was measured at approximately 10 to the minus 5 meters per second squared. That is weak by rocket propulsion standards, but significant enough to alter the orbit measurably over weeks and months. And critically, this acceleration enabled the object to adjust its trajectory in ways that would become significant later. Anomaly 4. The anti-tail jet, July through November 2025. In late July, ground-based observations and Hubble Space Telescope images revealed something that should not exist. 3I/ATLAS was producing a jet of material pointing directly toward the sun. This is called an anti-tail, and while it can occasionally appear as an optical illusion due to viewing geometry, detailed analysis confirmed this was not an illusion. Material was actually being ejected sunward against solar wind and radiation pressure. Comets always produce tails pointing away from the sun because solar wind, which consists of charged particles streaming outward from the sun, pushes gas and dust away. You cannot have material naturally flowing toward the sun any more than you can have a river flowing uphill, unless something is actively propelling it. The anti-tail persisted through July, August, and was still visible in November, when 3I/ATLAS re-emerged from behind the sun after perihelion. Hubble images taken on November 22nd clearly show the structure extending toward the sun. Additionally, when NASA's Mars Reconnaissance Orbiter captured images of 3I/ATLAS during its closest approach to Mars on October 3rd at a distance of 29 million kilometers, those images confirmed a glowing extension ahead of the object along its direction of motion. This is consistent with a beam of particles or light being projected forward, possibly to clear a path through interstellar dust or to detect obstacles ahead. That is exactly what you would expect from a spacecraft traveling at high velocity through space, not from a passive chunk of ice. Anomaly 5. Extreme nickel production, October 2025. In early October, spectroscopic observations detected something unprecedented. 3I/ATLAS was emitting extremely high levels of nickel atoms in its coma. Nickel is occasionally detected in comets, but at very low concentrations. It is a trace element, not a major component. But 3I/ATLAS was producing nickel at levels hundreds of times higher than any known comet. On October 1st, researchers published data showing nickel emission lines in the spectrum that were so strong they dominated other elemental signatures. Nickel is a metal commonly used in aerospace engineering and spacecraft construction because of its strength, corrosion resistance, and high melting point. Finding extreme nickel concentrations in what is supposed to be a natural icy comet is profoundly anomalous. One explanation is that the object contains a metallic core or structure that is being heated and vaporized by solar radiation. But natural asteroids and comets do not typically contain concentrated metallic nickel in the quantities being observed. Anomaly 6. The Hill Radius Precision, calculated October 2025. In October, Professor Loeb calculated the future trajectory of 3IATLAS and discovered something extraordinary. The object's closest approach to Jupiter on March 16, 2026, will occur at a distance of 53.445 million kilometers, with an uncertainty of only plus or minus 60,000 kilometers. Jupiter's Hill radius, the boundary where Jupiter's gravity dominates over the Sun's gravity, is 53.502 million kilometers. The forecasted passage distance matches the Hill radius to within the margin of observational error. The probability of this being coincidence is 0.00004. That is 4 chances in 100,000. This precision was enabled by the non-gravitational acceleration observed earlier. Without that acceleration, the trajectory would have been different. The object adjusted its path to target this specific gravitationally significant distance. At the Hill radius, an object with the right velocity and approach angle could be captured into orbit around Jupiter. It is the boundary between freedom and capture. If you wanted to release satellites or probes into Jupiter orbit with minimal fuel requirements, you would target the Hill radius. It provides maximum flexibility for orbital insertion. Anomaly 7. Wobbling Jets, December 12 and 27, 2025. In mid-December, Hubble Space Telescope captured detailed images of the jet structures emanating from 3IATLAS. What they revealed was stunning. The object has multiple jets, and those jets are not stable. They wobble. Images from December 12th and December 27th show that the jet directions oscillate back and forth with a regular period. The jets are arranged in symmetric patterns, 3 of them spaced exactly 120 degrees apart, plus the anti-solar jet pointing sunward. But unlike natural cometary jets, which turn on and off randomly as different areas rotate into sunlight, these jets maintain their geometric spacing while periodically changing direction. The wobble has a measured amplitude and a regular period that correlates with the object's rotation. This is consistent with thrust vectoring, a technique used in spacecraft propulsion to change the direction of thrust without rotating the entire craft. Natural geology does not produce wobbling jets with regular periods and maintain geometric symmetry. Anomaly 8. Symmetric jet structure, the 1st of January 2026. On January 1st, 2026, Professor Loeb published detailed analysis of the Hubble images showing the symmetric jet structure. 3 jets spaced exactly 120 degrees apart in a perfect equilateral triangle. In nature, you do not get perfect geometric symmetry. Natural processes are chaotic. Surface features are irregular. Ice deposits are randomly distributed. You do not get 3 vents arranged with mathematical precision around a nucleus. But if you were designing a propulsion or attitude control system for a spacecraft, you would place 3 thrusters symmetrically to provide balance control in 3 dimensions. The configuration observed on 3IATLAS matches the classic design for spacecraft maneuvering systems. Anomaly 9. The Opposition Surge Alignment, the 22nd of January 2026. On January 22, 2026, an extraordinary event occurred that happens less than once per century for any given comet. 3I Atlas aligned to within 0.69 degrees of the Sun-Earth axis. This means Earth passed nearly directly between the Sun and the object, creating what astronomers call an opposition geometry. The alignment was not instantaneous. The object maintained a phase angle of less than 2 degrees for approximately 1 week, from January 19th through January 26th. This extended opposition window provided unprecedented opportunity to study the object's surface and the dust it has shed. During this alignment, Hubble captured remarkable images revealing a quad-jet structure, including 2 jets pointing sunward and 2 trailing anti-sunward. But here is what makes this significant beyond the scientific opportunity. Opposition alignments are random events determined by orbital mechanics. You cannot predict when they will occur for an object whose orbit is determined solely by gravity. But if you have propulsion and can adjust your trajectory, you could potentially time your approach to create favorable observational geometries. The fact that 3IATLAS happened to pass through this rare alignment during the period of most intense scientific scrutiny is either extraordinary luck or deliberate timing. Anomaly 10, Extreme Polarization, January 2026. Ground-based polarimetry from the Very Large Telescope in Chile, conducted during the January opposition alignment, detected something unprecedented. Linear polarization in the antitail of 38%. This is extraordinarily high. Typical comets show polarization of 10 to 20% depending on viewing angle and dust particle properties. 38% is far beyond the normal range. Such high polarization suggests an abundance of submicron silicate grains with very specific size distributions and compositions, unlike any solar system comet observed to date. Achieving this level of polarization requires particles with extremely uniform sizes and shapes, which is difficult to produce naturally. It is much easier to produce if the surface has been deliberately processed or manufactured with specific optical properties. Anomaly 11, Unusually Large Particles, the 25th of December 2025. Analysis of the dust being shed by 3IATLAS revealed another anomaly. The particles are much larger than typical cometary dust. Normal cometary dust consists primarily of submicron particles, smaller than the wavelength of visible light. These scatter sunlight efficiently, creating bright, diffuse comet and tails. But spectroscopic analysis and scattering models indicate that 3IATLAS is shedding particles that are much bigger, in the range of hundreds of microns to millimeters. These are not dust grains, these are pebbles. Natural sublimation of ice typically releases small particles that were frozen into the ice matrix. Large particles require mechanical ejection, like explosive outgassing or deliberate venting. The size distribution of ejected material tells you about the mechanism producing it. Small, uniform particles suggest gentle sublimation. Large, varied particles suggest mechanical processes. 3IATLAS is producing the latter. Anomaly 12, Hiding Behind a Veil, the 27th of December 2025. Observations indicate that the nucleus of 3IATLAS is obscured by an unusually thick layer of dust. Astronomers cannot see the solid surface clearly because it is hidden behind a dense cloud of material. For most comets, the nucleus becomes visible as the coma dissipates with distance from the Sun. You can measure the nucleus size and rotation directly, but 3IATLAS remains obscured even as it moves away from perihelion and activity should be decreasing. This suggests either the object is producing dust at an extraordinary rate, or the dust has optical properties that make it unusually opaque. Either way, it prevents direct observation of the surface. which is exactly what you would want if you did not want the surface structure to be visible to external observers. Anomaly 13, Rapid Post-Perihelion Outburst, late January 2026. After perihelion on October 29, 2025, 3I, Atlas re-emerged from behind the Sun in early November. By late January 2026, NASA's Spheric Space Telescope, which had been launched in early 2025 to survey the sky in near-infrared wavelengths, observed something remarkable. The object underwent a massive brightness increase, much larger than expected from normal post-perihelion activity. For several days, the comet brightened by more than 2 magnitudes, becoming visible to amateur astronomers with modest telescopes when previously only professionals could observe it. Outbursts are not uncommon in comets, but the intensity and timing of this one were unusual. It occurred weeks after perihelion, not during closest solar approach when heating is maximum. And spectroscopic analysis showed the outburst was dominated by carbon monoxide rather than water vapor, suggesting it originated from deeper layers of the nucleus where more volatile ices are stored. This is consistent with a controlled venting event from internal reservoirs rather than random solar-driven sublimation. Anomaly 14. Changed composition ratios, January 2026. Early observations of 3I/ATLAS showed a carbon-to-oxygen ratio in the coma that was unusually high compared to solar system comets, but by late January 2026, that ratio had dropped dramatically to approximately 1.1, remarkably similar to the ratio measured in Solar System Comet 9P. Temple, after NASA's Deep Impact mission, excavated subsurface material in 2005. This convergence raises a profound question. Do all comets, regardless of which stellar system they formed in, share common deep interior chemistry dictated by universal processes in protoplanetary disks? Or is the similarity coincidental, caused by selective outgassing that changes the observed ratios over time? Or is something controlling what material is being vented to alter the apparent composition? If you wanted to disguise a technological object as a comet, matching the expected chemical signatures would be essential. Anomaly 15. Duration and persistence of activity, July 2025 through February 2026. 3I. ATLAS has remained active continuously since discovery in July 2025. That is now 8 months of sustained outgassing and jet activity. Most comets show activity that varies significantly as they approach and recede from the Sun. Activity peaks near perihelion and drops off rapidly as the object moves away and solar heating decreases. But 3I/ATLAS has maintained relatively stable activity levels even as it recedes from the Sun, now at approximately 3.3 astronomical units as of February 2026. At that distance, solar heating is much weaker than near perihelion. Water ice should no longer sublimate significantly. Only more volatile compounds, like carbon monoxide, should still be active. Yet the jets persist. The wobble continues. The dust production remains measurable. This sustained activity at large solar distances suggests internal heat sources or controlled venting from reservoirs, not passive solar-driven sublimation. Anomaly 16. The coordination pattern. Now let me step back and look at the pattern that emerges when you combine these anomalies. An object arrives suddenly from interstellar space, already deep in the inner solar system. It is much more massive than previous interstellar visitors. It shows non-gravitational acceleration without typical cometary signatures. It produces an anti-solar jet that violates cometary physics. It emits extreme quantities of metallic nickel. It adjusts its trajectory to target Jupiter's Hill radius with extraordinary precision. It displays geometrically symmetric jets that wobble with regular periodicity. It aligns with a rare opposition geometry during peak observation period. It shows extreme polarization, suggesting engineered particle properties. It undergoes controlled outbursts. It changes its chemical signature over time, and it maintains activity far beyond what solar heating can explain. Each anomaly individually might be explainable through unlikely but possible natural processes, but the combined probability of all these anomalies occurring together in a single object is astronomically small. Professor Loeb has calculated that the combined occurrence probability, assuming each anomaly is independent, is the product of their individual probabilities. When you multiply 0.00004 by 0.001 by 0.01 and continue through the list, you end up with a number so small it is effectively zero. You are more likely to win the lottery 10 times in a row than to have all these anomalies occur naturally in a single comet. The silence and the countdown. Here is what troubles me most about this entire situation. With this accumulation of anomalies, with this weight of evidence, you would expect intense debate in the scientific community. You would expect major press conferences. You would expect NASA and ESA to be clearly stating either that they have natural explanations for everything or that they are genuinely puzzled. Instead, what we have is relative silence. NASA held a press conference on November 19, 2025, where officials stated that 3IATLAS appears to be a natural comet, but they did not address most of these anomalies in detail. They did not explain the Hill radius targeting. They did not explain the anti-solar jet. They did not explain the symmetric wobbling jets or the extreme polarization. They simply asserted natural origin and moved on. That is not how science normally works when confronted with genuinely puzzling data. Meanwhile, telescope access has been restricted. Independent researchers have had observation proposals declined. Data from some observations has been delayed or not fully released. This is the pattern of controlled information management, not open scientific inquiry. And that brings us to March 16th. 24 days from now, 3IATLAS will pass Jupiter at the Hill radius. If it follows the predicted purely gravitational trajectory, passing at exactly 53.445 million kilometers, that will support the natural comet hypothesis despite all these anomalies. Extraordinary coincidence, but possible. If it deviates from that trajectory by any measurable amount, if it passes closer or farther than predicted, that is proof of active trajectory control. Proof of propulsion. Proof that this is not a natural object. Every major observatory on Earth and in space will be watching. The data will be undeniable, and then we will finally know the truth about what 3IATLAS actually is. Until then, we have these 16 documented, verified, peer-reviewed anomalies. And the question they collectively ask is simple. How many coincidences do you believe in before you admit you are looking at something designed?